Alright, I've got a new sculpture to build. Savina's company is moving into a new office this fall, and they want some art to liven up the place. So I went and put together a proposal, and they liked it. Now I've got to figure out how to build the thing and see if I can't pull it off. The company's called Ripple. It's named after the ripple effect, which is the idea that in an interconnected world, some action over here in one part can have an influence that spreads outward and affects other parts. So I'm going to try and build a sculpture that somehow embodies the ripple effect. I'd like it to be kinetic and possibly interactive. So maybe it's made of many parts and someone can come up and touch one of the parts or pluck it and set that part in motion. And it's going to somehow influence neighboring parts, and before you know it, many parts are going to be set into motion. So your action can have an influence that ripples throughout the whole system. So check it out. I've got this prototype here that I put together for the proposal. It's with a few pieces of wood and some wire. And it has these vertical rods that can vibrate and they can sway back and forth. You can reach out and you can pluck one of them, and it takes on a really nice motion. You can even see a sense in which when you set one of them in motion, they all start to go into motion, especially if the platform is a little bit loose or a little wobbly. You can see the motion in the whole system. So I think it's a great start, but it's not perfectly capturing the behavior that I'd like to see, which is you set one piece in motion, and that motion is going to propagate through from neighbor to neighbor throughout the whole system. Here, you kind of set one piece in motion, and then it, through transfer through the base, sets the whole system in motion. I'd like to see more of a wave phenomenon, like what you'd see when you throw a pebble into a pond or a puddle of water. Motion starts on one part, and that travels outward at a certain rate until it has impacted all the parts. So I think what's going to be key is some way of connecting rods to neighboring rods more directly. My first instinct was to use string. And maybe if you attach string to the caps of all of the rods, then of course they're going to be connected directly to their neighbors. They'll be able to pull on each other, but they won't be able to push on each other. So you might end up with something that's kind of jerky, or you might end up with them all sort of moving exactly in unison. So what about the possibility of attaching the strings lower down? That way they're not going to have quite as much leverage on the rod. The rods are still going to have some flexibility to sway up top, but underneath they're going to subtly be pulling on each other, and maybe you get some sort of nice synchronization behavior. Maybe you'll get a traveling wave. There's another idea, which is magnets. Maybe magnets are just the thing. One of the best parts of magnets is that they're invisible, so they're not going to interfere with the clean lines in the form of this sculpture. But you know, I tried magnets, and I wasn't so happy with the result. So with the magnets, it's a little more chaotic than what I would like. It's definitely displaying the neighborly influence behavior. If I pluck one, it's going to start swinging, and it's going to set the neighbors in motion, and the motion's going to travel through the whole system. But it seems a little bit too jerky, a little bit too rough. The thing with the magnets is that they don't really exert a force until they get real close together. So while this is pretty good, certainly simple and easy to construct, still have my hopes on something better. I think the problem lies in the force characteristics. Let me show you what I mean. So I've gone and I've made some graphs. Here's the behavior with magnets. I have force on one axis and distance on another. So if the distance changes a little bit, you see the force changes a little bit. Okay, change the distance a little more, the force changes a little more. Change the distance a little more still, and boom, all of a sudden the force starts to change a lot. It really takes off. It's got this exponential relationship. Depending on how you model it, the force can change as the square of the distance or as the cube of the distance. I think with how I have it here with physical magnets that are farther apart from each other than their own size, I think what you get is a cubic relationship. So the force changes to the third power of the distance. That's a lot. That's where you get the jerkiness from. They don't start to influence each other until they get really close. Let's compare this with twine. So twine here, well, twine is even worse. before a certain distance, which is, the length of the twine, you don't really feel anything. It's just you're pulling on slacked rope. But once you get to the distance, then, boo, the force really explodes. It goes almost straight up. And you feel it all of a sudden. You can't even go any further along in distance. The force is just going to pull directly once you reach the distance. So I think from that standpoint, twine is even worse. What I think would be the most ideal is the following. Springs. Springs are famous for their linear relationship between force and distance. You change the distance a certain amount, the force changes by the same amount, or it's directly proportional. So you double the distance, you double the force. Nice and simple. Magnet, however, if you double the distance, the force is going to go up by 8 times, since it's a cubic relationship. So in terms of profiles, I think springs are going to be the winner. With springs, each rod is going to start to influence its neighboring rod the very moment the distance starts to change, and as the distance keeps changing, the force is going to keep changing directly proportionally. I think it's going to work out the best. So I went around to a few hardware stores looking for springs, and I couldn't quite find what I had in mind, and what I could find was expensive. So I think I'm going to try and see if I can't make my own springs. I went and got some wire that I had around, stainless steel wire, and wrapped it around a rod that I put in the drill. And that technique works pretty well for forming it, but this particular wire didn't have any springiness to it really. It just deformed and stayed that way. So I think I'm going to need to do some research and find out exactly how to go about building your own springs. But for now, I'm going to leave the springs research and come back to it later once the project is farther along. Next, I'm going to focus on the interconnected elements, the pieces that will do the oscillating, which will be the subject of my next video.